Good morning, students. We started the second chapter of chemistry, acids, bases and salts last week, and in the previous video we studied about the action of acids and bases on different indicators. Today we will study about the general chemical properties of acids. Now, acid, as I told you earlier, the word acid has been derived from the Latin word acidus, meaning sour. So, all acids are sour to taste. The taste of vinegar is due to acetic acid, while that of lemons and other citrus fruits is due to citric acid. Now, acids are classified into organic acids and inorganic acids depending on the source from which they have been derived. So, organic acids are those that are present in fruits and naturally occurring substances. They are found in animals and plants products. Okay, so some examples are curd contains lactic acid, tamarind, imli contains tartaric acid, apples contain malic acid, and so on. Inorganic or mineral acids are obtained from minerals, and some examples are hydrochloric acid, sulfuric acid, phosphoric acid, etc. etc. Okay, here is a list of some food items that are acidic, and here is the name of acid present in them. So the citrus fruits such as oranges and lemons, they contain citric acid. Curd contains lactic acid. The sting of bees and ants, formic acid. Tamarind and grapes, tartaric acid. Apples have malic acid. Vinegar is sour because of acetic acid. Tea also has a little amount of tannic acid. Tomatoes, oxalic acid. And the food preservative that is used to increase the shelf life of certain food items such as jams, jellies and sauce contains benzoic acid. Okay, here is a list of some inorganic acids that have been derived from minerals. So hydrochloric acid, HCl, nitric acid, HNO3, sulfuric acid, carbonic acid and phosphoric acid. As you can see, all these acids, it is obvious from the molecular formula of the acids that all of them have hydrogen, and so when they will dissociate, they will all produce hydrogen as their positive ion. For example, when the aqueous solution of hydrochloric acid, when hydrochloric acid is dissolved in water, it dissociates, breaks up into the two ions, positively charged hydrogen ion and the negatively charged chloride ion. This positively charged hydrogen ion will combine with water and they will produce hydronium ions H3O+. On the basis of this general property of acids, we may now give them a definition. So acids are therefore defined as those chemical compounds which when dissolved in water produce hydronium ions H3O+. Alright, now this is a very basic definition of acids. In your higher classes you will study the concept of acids and bases in terms of electron transfer also. Now let us start the general properties of acids. So, as it has been already told to you, acids are sour in taste. Their action on different types of indicators we studied in the last video. For example, they turn blue litmus red. Okay, they change the color of methyl orange to red, and phenolphthalein remains colorless in acidic solutions. Now, one more thing about acids is their corrosive nature. Corrosive meaning burning. So acids are corrosive in nature. That means they produce a burning sensation on the skin and holes in the clothes on which they fall. Okay. Now because of their corrosive nature, they are not stored in metal containers. Acids can never be stored in metal containers because they will create holes in the containers, and they are always stored in glass containers or ceramic containers because they are not attacked by acids. And because acids are corrosive, there are chances that they will cause accidental burns, and to avoid these accidents there is always a mark of danger on the bottles in which acids are stored. Okay, so they should be handled with extreme care in the laboratories or anywhere else, because of their they may cause painful blisters on the skin. Okay, so these are some general properties of acids and bases. Now we study the first chemical property of acids, the reaction of acids with active metals which are reactive. Now the general equation is metal plus dilute acid gives salt and hydrogen. That is, if zinc metal, solid zinc metal, reacts with sulfuric acid and they produce zinc sulfate and release hydrogen gas. Magnesium reacts with hydrochloric acid and they produce magnesium chloride, the salt, and hydrogen gas is liberated. In the NCERT book, there is an activity to explain this. This is also a part of your practical syllabus to study the properties of acids and bases, and so you should study about this activity from the NCERT book. It's given on page number 19, activity 2.3. Now in this activity, we have taken a test tube, and in this test tube we take some zinc granules. Okay, zinc is grey in color, and we take some tiny granules of zinc in the test tube. On this we will pour dilute sulfuric acid. So the acid used here is dilute sulfuric acid. We will take a cork to seal the test tube and pass a delivery tube. Okay, the other end of the delivery tube is dipped in soap solution. Now when the reaction begins, we will see bubbles in the test tube. The bubbles indicate the evolution of a gas. These gas bubbles will rise up in the delivery tube and pass through the soap solution. When a gas passes through soap solution, it will form soap bubbles. So these soap bubbles will be filled with hydrogen gas. Now when we bring a lighted candle near the bubbles, the hydrogen gas inside the bubble will burn, the bubble will burst, and the gas inside will burn, producing a pop sound. This is a characteristic test of hydrogen gas. So acids react with sulfuric acid has reacted with zinc and it has produced a salt which is in the test tube. Hydrogen gas liberated is tested by bringing a lighted candle near the soap bubbles. Okay.